Hi, I'm Liz Nedden. Let's have a look at what the normal distribution is. So a normal distribution is a continuous distribution. So that means the data is continuous, measuring heights, measuring weights, measuring the length of something. So anything where the numbers can be decimals. So those are our continuous distributions, and it has two parameters. So two key pieces of information we need to know. We need to know the mean and the standard deviation. And once we know those two things, we can work out the probabilities of this theoretical distribution. So a reminder, your mean, the mean is looking at where the middle is. So it's when we add up all the data and divide by how many data values we have, divide by the sample size. So here is a little video which will just show you what happens when we change the mean. So as we change the mean, where the centre of the distribution is, that is what's moving around. And that's why it's one of the key parameters, because we need to know exactly where that centre is. Equally, the standard deviation. The standard deviation is a measure of how far away each of the data values is from that mean. So that's why you can see the little red arrows between each data value and the mean. So if we have a look at this shows you what happens. This is getting a small standard deviation, so the data is getting narrower, or a larger standard deviation as the data gets more spread out. So the standard deviation is measuring how spread out or close those data points are to each other. So that's what a standard deviation is. So when we write notation for it, we often talk about some distribution x, and there's the little squiggly line, which means x is approximately, because we're usually modelling data. So x is approximately a normal distribution, and then in brackets we put the two parameters, the mean and the standard deviation. So the first letter mu, it's a U with a longer tail at the front. That's the Greek letter, and that is mu, it's called. The second one is our standard deviation, and that's a Greek letter sigma, which stands for standard deviation. So this image here is just trying to show you that if I vary my distribution, so if my distribution changes, the mean, for example, or the standard deviation, in this case you can see the standard deviation is changing, there are these three regions that we talk about. And these three regions are what we call plus and minus 1 standard deviation, 2 standard deviations, or 3 standard deviations away from the mean. So when we know all the data in the centre, that central plus or minus 1 standard deviation, that's about 68% of our data. Plus or minus 2 standard deviations is about 95% of the data. So even when I change that standard deviation, the area under the curve in these regions, that area stays the same. And so this is what we talk about often when we talk about being 1, 2, or 3 standard deviations away from the mean. And 95% is quite a common one for us to use. So if I've got data which has a mean of 8 and a standard deviation of 1.5, to sketch that standard deviation, I'm going to first of all draw my mean line down there in the middle, and so that's going to be at 8. So in terms of my number line, if I've got a number line going across there, that would have a value at 8 in the centre. Now a standard deviation of 1.5, well, if I add 1.5 to 8, that will take me up to 9.5. If I add a second standard deviation, so 9.5 plus another 1.5, that will take me up to 11. Add on another standard deviation, so another 1.5, that takes me up to 12.5. Now I'm going to reverse and go below that. So from that mean of 8, I'm going to go back by 1.5. So I'm going to subtract 1 standard deviation, so that will take me to 6.5. Subtract another standard deviation, the second standard deviation, below the mean, and that will give us a value of 4. Sorry, my brain just went slowly. Subtract another standard deviation, so another 1.5. So this is 3 standard deviations below the mean. that will take me down to 2.5. So that tells me between this value of 2.5 and 12.5, that area all in between there is approximately 95%. Sorry, 99% for 3 standard deviations. And 2 standard deviations, I would have about 95% of my data between the value of 4 and 11. And about 68% of my data between 6.5 and 9.5. So that's often how we want to start thinking about this idea of means and standard deviations. Second example, so let's sketch one with a mean of 5 and a standard deviation of 1. So we'll put our number line across the bottom there. We're going to draw our mean in the middle, and that's the mean there of 5. Now if it's got a standard deviation of 1, it means we're going to add 1, add another 1, add another 1. And we're going to subtract 1, subtract 1, subtract 1. And so there's my 1, 2 and 3 standard deviations above and below the mean. Okay, so normal distribution's a lot of the data in the middle, and it gets less as we get out towards the tail. Thanks very much for watching.